All right. I also do not know why Microsoft PowerPoint put the double I over the double dot. I don't know. I don't know. It did it itself. It said I spelled it wrong, and then that's what it did. All right. So again, hopefully you made the connection now that midline, amplitude, and period are things you already know. Okay. Your midline is just a vertical translation going up and down, right? Your amplitude is your vertical dilation. How much are you stretching or compressing vertically? And your period is just a horizontal dilation going left and right. And remember that our X's are liars. So if it says plus, we're actually going to the left. If it says minus, we're actually going to the right. Okay. Um, so when we're looking at this and we're writing all our transformations, our sinusoidal functions in transformation form, this is what we're looking at. We have our A, our B, and our D. So our A, that's our vertical stretch and compression, our vertical dilation. Our B is our horizontal stretch and compression, our horizontal dilation, and our D is our vertical translation up and down. Okay. So those are the things that we need to be comfortable and able to identify. All right. When we have a vertical dilation by a factor of A, that means we're simply multiplying our Y's by whatever A is, right? So vertical dilation means we have an A factor, and to find those in this point is A times Y. I don't know what happened to my A. Just go with her. I think I may have dropped my pen one too many times, and she's getting a little mad at me or maybe I need to change the tip of the pen. I think I have a few more in there. All right, a vertical translation is your D. Your vertical translation is saying that you're taking D and it's going to be Y plus your D, right? So whatever your Y value is, you're adding that D amount to it, okay? If D is negative, then we're obviously subtracting, correct? All right. Our horizontal dilation, remember our X's, our B's, our X's are liars. So anything associated with the X is a liar. Even though it looks like it's multiplication, you're actually multiplying by the reciprocal, okay? So you're multiplying reciprocal, which means that you're taking your X values and dividing them by your B. Okay. Just like when it says add, we're actually subtracting. When it says subtract, we're actually adding. Same thing with multiplication. It says multiplying, but we're actually dividing. Okay. And that's what you're doing to each value. That's how you look at it from a transformation point. So that's what we're taking the amplitude, the midline, and our period and putting into terms of things you already should know in your brain, because all Algebra 2, our whole course is centered around transforming functions, right? Moving things left, right, up, down, stretch, and compress. All right, so here we have a sinusoidal function, and this sinusoidal function is clearly labeled with everything that we need. Can we write the actual function model for it? Yes, we can. Do we feel comfortable being able to do that? Okay, well, let's go piece by piece. So the first thing we need to identify is our A. Remember, your A is tied to your what? Your A is your vertical stretch or compression, right? It's your vertical dilation. So that's your amplitude. So when we're looking for our A, we're looking for our amplitude. Do we have our amplitude? Yes. So we know that A has to be what? 6. We know that A is 6. Okay. The next easy thing to identify is your D. Your D is your midline. Is our midline clearly labeled for us? Yes. What is our midline? 3. So we know that D equals 3. Okay. The next thing is our B. Our B is what we are going to have a little like, ooh, how do I figure out the B? For your B, you're going to determine how much has it stretched or compressed along the horizontal. Okay. Meaning that did it swish in or did it expand? If we look at this sine function, and I know it's a sine function because I'm about to highlight it as a snake. Do we see that? So I have a positive sine function right here, right? Looking at this positive sine function, normally what is the period of that sine function? Pi, 2 pi, right? Our period is normally 2 pi because we go around a unit circle. And how much is it to go around a unit circle? 2 pi, right? So normally our sine wave takes 2 pi. That's the period of it. Well, what is the period of our sine function now? Pi. It's only pi. So what did we do to that 2 pi? We didn't multiply, we divided by 2, right? So that means our B has to be 2 because we horizontally compressed it. Does that make sense? So we know that looking at what pi is, currently our period is pi. Normally our period is 2 pi. How did I go from 2 pi to pi? I had to divide by 2. So therefore our b equals 2. Does that make sense? We compressed it. Yes. Remember, x's are opposites. Okay? The bigger the number, remember we're playing the accordion. The more pressure I apply, I am compressing it. So the bigger the number, I'm actually shrinking it in. I'm applying more pressure, right? When I lessen the pressure, the smaller the number, I'm stretching, I'm relaxing along that horizontal. Compress, stretch, compress, stretch, okay? So it's the opposite. X's are liars. They try to confuse you, maybe you should just let them say an X. All right. So now do I have everything I need to write the sinusoidal model? I do. So we know that H of theta equals 6 times the sine of 2 theta, not a pi. Can I transform it? 2 theta plus 3. And that would be my model. So you go piece by piece, identifying, and then you just write it out. Is that doable? Okay, so you identify essentially, what is your midline, what is your amplitude, and how is your period being changed. Make sense? And you can go backwards. So if doing this doesn't work for you, remember your period equals 2 pi divided by b, right? So if I know that my period is pi, when I set that up as an equation to solve, this equals pi over 1. How do we solve a proportion? Cross multiply, right? So when I cross multiply, pew, pew, I get 2 pi equals pi times b. Pi is on both sides, so therefore b equals 2. So even if you can't see it visually, do the math, because p always equals 2 pi divided by b. Okay? And it just comes down to you setting up a proportion and cross multiplying and solving for your b. So if you had a hard time understanding how we went from 2 pi to pi and knew that it was 2, always do the math. Okay? There's going to be a math reason tied behind it. Are you guys ready to try? Okay, so on the next function, you're going to identify the amplitude. What does the amplitude represent? What does our amplitude represent? Our vertical stretch, right? Our A. Then you're going to find your midline. What does our midline represent? Vertical translation. And then you're going to find your B, which is tied to your period. Okay? Are you ready to try? All right, none of it's labeled. Your job is to find those things and then interpret them into the function. Go be great. All right, so up first, what is my amp? My amp is 3, which makes it my what? My A. Perfect. What is my midline? It's also 3, which makes this my what? D. Perfect. What was my period? 2. And how did that change? Well, it was pi, but I'm saying, hold on. Let me rewrite that. I wanted the period, not the actual B value yet. What was my period? Pi. And how did that change? It was cut in half. So our B has to be 2 because we divided it by 2. Does that make sense? All right. Do I have everything to write my function? Yes, I do. So our function would be f of theta equals 3 sine of 2 theta plus 3. Yay? Okay. Perfect. I knew you were geniuses. All right. So here we have this graph, and it wants us to find all the values that are listed. The period is pi, and the amplitude is 2. Is that true? I'm asking y'all. Which is it? Well, I just got to it, so I'll give y'all a moment to look over it. Some people, because it's correct. That's our exactly. Yeah. All right, I guess you'll know what you're doing now. All right. Whether you start here, either way, it's still gonna just be a half a pie makes a whole pie. A half a pie makes a whole pie. It's actually negative though, if y'all notice. We have a negative. Did you notice it was negative sign? Oh, just saying, just checking. It doesn't matter. All right, next one. All right, go be little geniuses since we know what we're doing. Other examples of possible non-calculator. Here you go. What is it? Bad. Because I thought you said A. I was like, why'd you say A? Okay. Yeah, anyways. All right. So going back. Yeah. So it's in the bottom of that bucket. It's not really tissue or napkin, but they're softer than Picton. All right. So again, remember, when you're doing this, you should always start off by finding your midline. Now, how do we find our midline? You're averaging your max. I can write plus your min divided by 2. So when we do that, our max is 6, our min is negative 4, right? Divided by 2, and that gives us, easy enough? Okay. All right. Now that we have our min, can I find my amp? Yes, because your amp, there's 2 ways. It's either going to be your max minus your mid or your mid minus your min. Does it matter which one you do? No. So we have amp equals our max minus our mid, which gave us, what was our max? 6. And then 6 minus 1 is, so our amp is 5. So you should, boom, boom, gone. Okay. Now they try to get you here. Pi is actually your what? Period. It is not your B, it is your period. Your period equals pi, right? Which means that this has to equal 2 pi divided by B. And at this point, we know what this means and what this looks like. That means that it had to be 2 because we compressed. Make sense? All right. Last one. Match the graph to the change. I really hurt my ankle. So at this point, hopefully we've recognized a little bit of patterns, right? Quick and easy things to figure out. First off, when you see 2 as your B, you know that that means your period equals what? Pi. So when our B equals 2, we know that our P equals pi. So automatically, when I look up here, this one goes zoom, 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 zoom. That one goes to pi. Zoom, 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 zoom. Does this one go to pi? No. Doom, 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 doom. This goes to pi. Boom, boom, boom. Does this go to pi? No. So automatically you can eliminate by looking at those things. Next comes the easy part, which is your amp and your midline. So now we know that our midline needs to be at -1. So where is this midline at? 1. Where's this one at? So the answer had to be C. Ta-da! Easy peasy. Perfect.